Hey everyone, welcome to the most opinionated space podcast on the internet,
Ad Astra, the podcast where we integrate space, policy, and technology.
I'm Jack.
And I'm Newton.
I have a Master's of Public Policy degree with a concentration in science and space policy.
And I'm a PhD in computer science and an all-around tech geek.
Okay, guys, don't forget to follow us on Twitter at @AdAstra_podcast, like us on Facebook, and subscribe to our mailing list on Elemental FM to get regular updates from the team. And if you like what you hear, give us a review on iTunes and recommend us on Overcast.
And today we're going to have a shorter section for Latest in Washington than we did last week, where we cover U.S. Vice President Mike Pence's recent remarks at Kennedy Space Center in the Latest from Washington section. We're going to talk about climate change at the G20 summit as our space news highlight of the week. In international news, we're going to talk about ESA and JAXA picking up the legacy of traveling to Mercury. And latest in tech, we'll talk about recent news in the exploration of both Jupiter and the Kuiper Belt. And in Coming to Space, we'll talk a little bit about the next Mars orbiter coming from NASA. So, Jack, latest in Washington.
Well, it's really latest from Cape Canaveral. So as everyone remembers from last week,
it's always about Florida. It's
always about Florida. Space, Florida this, space, Florida that. Anyway, so there's this NASA facility in Florida that Mike Pence was at. He, as everyone knows, if you listen to last week's episode, he is now the chair of the National Space Council, NSPAC, and he went to Kennedy as his sort of inaugural address about what him and the administration, therefore their space policy is going to be. They haven't released any documents. They haven't released anything but the transcript of the speech, which is included in the show notes. But he talked about some pretty vague stuff. He of course talked about, launching American astronauts on American vehicles. He talked about, Apollo 11, Buzz Aldrin was there. So he talked about Apollo 11 going to the Sea of Tranquility and, was here you launched America's space shuttles and America's astronauts to orbit this blue marble. Really standard space speech stuff. Didn't really highlight too much other than the fact that he brought in a little bit of, how should I put this? A little bit of like nationalism into it. So there's a line in here about using space as a way to save the West is the way that he phrases it.
Which is interesting because space typically has some, usually most space speeches have some nationalist flavors, a few hints of nationalism, but more in the sense of we're Americans and we were doing this, because America, right?
Yeah.
But yeah,
this was especially that. The line in here is he's talking about the president's speech before a joint session of Congress. He goes, President Trump reminded us that the defense of the West ultimately rests in the words, not only on means, but also on the will of our people to prevail. Finally, the president reminded the world today that our own fight for the West does not begin on a battlefield. It begins with our minds, our wills, our souls, our freedom.
You want to elaborate on Fight for the West?
I think there are some blogs, Infowars.net, that maybe if you're really interested in what this fight for. No, this is like purely nationalistic stuff. This is as deeply nationalistic, as enigmatic of the Trump administration as you can get in a space speech.
I'm sorry, but like today, there were a ton of BBC reports about kicking ISIS out of Mosul, and they're over there talking about fighting for the West. This is. I don't know. We're not a politics podcast. We're a policy podcast. So I'm going to leave it alone.
We blur that line a little bit here at the Ad Astra podcast. It was gratuitous. A lot of what he was saying. like, of course he was going to mention Apollo. Of course he was going to mention the space shuttle. And of course he's going to sort of have that nationalistic flair, not just because it's a space speech, as you mentioned, which typically do have like a nationalistic, go America, hoorah, flair to it, but also because he's speaking on behalf of an administration that was elected on a very populist nationalistic agenda. I mean, this is what they want. And I mean, I can't speak for Mike Pence. I don't know if he actually believes any of this stuff. But he's speaking on behalf of the administration, and he's speaking on behalf of their policy objectives. And this is what we're seeing here, that they're going to use space as sort of this launch pad, pun intended, for other policy proposals. One of the big things that he calls for is a return to human space exploration. Now, I don't know what he means by that, because we already spend about half of NASA's budget already on human exploration endeavors.
I mean, it's colloquial. This is more about, about human spaceflight beyond low Earth orbit, right? That's really what he's getting at. So I think that's it. He's trying to speak to a more general audience than just us, who like understands that, we've been doing human spaceflight, just not to places like the moon, like we did in the Apollo era.
Yeah. So. I mean, it might be a little also enigmatic of the lack of knowledge that the administration has on the nuance of this issue. I mean, this is an administration that barely knew how to stand on its own 2 feet when it got in, let alone the intricacies of space policy.
Tell us how you really feel, Jack.
But like, I mean, it's 0.5% of the federal budget. Like, they have bigger things to worry about right now. It makes sense to me that they're not taking any dangerous, or they're not pushing the envelope too much with their space speeches or their space policy. I mean, it has that nationalistic flair that we were talking about. It has the hallmarks of the administration written into it, but it's not saying, okay, we're going to have humans on Mars by 2022, as the president wants, I guess, jokingly, quote unquote, jokingly. But like, it doesn't push the envelope, but it brings back this rhetoric that human space flight is second rate, to planetary missions or to robotic missions or like the James Webb Space Telescope. I mean, I'm sure he would not have given this exact same speech at JPL. I mean, he was at Kennedy. There's a reason why he was able to talk about human exploration in such a way, because he was in a friendly audience. But it doesn't make sense to me, this rhetoric that they're pushing of, oh, we have not been prioritizing human spaceflight, because it just buys into the same narrative that we've been dealing with since 2011 when the shuttle program ended, which a lot of people just believed NASA stopped existing, that their only purpose was the shuttle program and that they didn't exist after the shuttle ended, when really they were doing a million other things and a million better things than shuttle. It's just there's no human on board, so there's no pomp and circumstance around it. Now, I mean, I think this ties deep within my own beef with the rhetoric around space, that it's not just humans, that we need to really be taking robotic exploration seriously. But it's just disappointing to see that really there's not going to be much headway made in 4 years. I'm not sure what we're going to name this episode, but I think our working title was Mike Pence isn't the guy, because it just seemed like when he was up there talking, and after reading the full remarks of the speech, it just doesn't seem like we're at the point that like this is going to be some massive turning point, right? Like,
I mean, I saw the speech as just bland vice presidential space speech.
And that's exactly what I'm saying.
It was comparable to most other speeches that I've seen from vice presidents, even / presidents on space. Yeah, there wasn't really anything that moved me.
Well, and that would be fine under Joe Biden, or that would be fine under Dick Cheney, because they didn't care so much about space. But this is a presidency that revived the National Space Council, that is basically made it one of their hallmarks of their campaign was space. I mean, I saw so many ads that was a picture of Donald Trump's face in the foreground, and in the background it was a shuttle launch. Like, this like the center point of their idealism, or their like nationalistic idealism. And yet this is nothing new.
Yeah.
It's same shit, different presidency.
Different toilet. Yeah. All right.
Different toilet. Different administration.
All right. Well, so fairly middle of the road speech. We'll see what comes in terms of policy in the coming months. But on to our space news highlight of the week. Speaking
and
of the administration,
this is a big one.
This is a big highlight of the week. So the 2017 G20 summit was last week. Jack, did you make it out there?
Yeah, Hamburg is lovely this time of year.
Yeah, so I've heard. But anyway, for those that are unfamiliar, the G20 summit is an international forum for the governments and central bank governors from the world's 20 major economies. They cover a number of cross-cutting political issues, from counterterrorism and national security to free trade to NATO to women's empowerment and climate change, which is why we're talking about it on this podcast. Now, if you recall, last month, the U.S. decided to withdraw from the Paris Agreement.
Despite, the U.S., quote unquote.
Yes. Despite the will of many of its states and major cities, the U.S. president portrayed the pact signed by 194 nations to cut planet warming emissions as a, quote, bad deal for America. In spite of that, the German presidency wanted to make the most of the, quote, renewed public policy interest for environmental sustainability, gender equity, and social inclusiveness in the spirit of the UN's Sustainable Development Goals, end quote. Notably through the promotion of renewable energy and further fossil fuel divestment in both industrialized and developed nations. So Germany was clearly on board, as we all knew. Now, the dynamic at the G20, as I've been reading about it, was fairly interesting. It seems like coming into this, the U.S. would be fairly isolated. But despite a bunch of memes on the internet, it actually seems like those aiming to isolate the United States on climate issues have softened their language just a bit to say that they hope an overwhelming majority embrace the Paris Agreement. Saudi Arabia has indicated that it's unlikely to climb on board, and Russia, Turkey, and Indonesia are sending mixed signals about how forcefully they'll actually declare their support for the Paris deal. And because of that, fear of the future of the Paris Agreement itself could be at stake. One weak statement, or one that fails to clearly cast the United States as a renegade on climate change, could signal that leaders are reluctant to jeopardize deals on trade or security by antagonizing the Trump administration over climate issues. And that's not to say that Europe's not pushing ahead. Recently elected French President Emmanuel Macron took the lead on climate change at the G20. In a very American manner, actually, he tweeted on December 12th, 2017, 2 years after the adoption of the Paris Agreement, France will hold a new summit on climate mobilization. He also tweeted a video of himself addressing the G20 summit with the statement, there's no going back on the Paris Agreement. In yet another tweet, he used the hashtag Make Our Planet Great Again. In yet another tweet, he had Donald Trump beating up a wrestler with Earth as its head. Now, I just made that up. That's not true, ladies and gentlemen. According to Reuters, Macron reportedly said Saturday that the climate summit would seek to mobilize public and private funding for the projects outlined by the Paris Climate Agreement. So what do you think? Do you think this did anything to change the U.S. president's mind on climate change, or the Paris Accords? I mean, Paris Agreement. I've got to stop calling them the Accords. This isn't Captain America's Civil War. do you think that this did anything to sway the U.S.?
So I heard this is a heard it here first, folks, that Donald Trump has said he's wrong, and he's going to completely reverse his decision. He's also growing out his hair and
Fake
deleted
news.
his Twitter account.
Fake news.
No, this is absolutely not going to do anything to change his opinion on it. It's unfortunate, but this is the world we live in, where the U.S. president isn't swayed by facts, that scientific evidence means nothing, and the news is fake. So, again, this is not a politics podcast. We're a policy and technology podcast.
What do you think about the world moving forward, though? I mean, do you even think that the U.S. will send representatives to this French summit in December?
Well, here's what's going to happen, theoretically, is that the administration chooses not to. But that, I don't think, precludes states and cities from doing so. I mean, you're going to see cities like Los Angeles and New York and San Francisco and Seattle and probably even DC send representatives on, quote unquote, on behalf of the United States, with absolutely no bargaining power, with absolutely no sway over the entire thing. But it's going to be a publicity stunt. So December 2017 is there's going to be a bunch of people from the U.S. there with no bargaining authority for the United States. But it's just going to, one, make the U.S. look worse internationally. We're already in a horrible position with the way that the president has been treating this issue and been treating our long-term allies, especially Germany and France, especially since Macron's election, has not been treating them very well. We don't have the best international rapport anymore. I don't see anything changing with the United States, but that's not going to preclude the rest of the world from moving forward. And that's what's the most dangerous part, I think, is, I mean, I've seen these arguments online that, you know, even with the Paris Accords, or geez, I'm doing it now. Even without the Paris agreements, we're still going to have better carbon emission standards than what would have been under the Paris agreements. And that might be true. I didn't look into, I mean, it's,
well, we can't go back.
I didn't.
That's the thing. You can't go back. Now, that's not to say that there's not a danger in stopping or extremely loosening regulation on folks who are polluting the atmosphere or other parts of the environment. However, there are some places that we just can't go back to. Our utility industry, economically, just cannot go back to polluting the environment. Like, they just for the most part, they just can't. Right?
It would cost so much more money to revert back to old ways that it's path
right.
of least resistance.
Right. And what we're talking about standing against here is a new world economy. And, you know, I'm not going to take the extreme stance to say that the U.S. will not be a part of that economy, but by not having its government make the investments that other world governments are making, we will be a, 15th, 16th rate player in that economy. Like, that's the problem with this.
Yeah, I mean, that's sort of I'm going to be kind of doom and gloomy now. Like, if the United States does not sign on to the Paris Agreement, or at least work with our international partners to find some agreement that works for us, we're going to lose our international bargaining power. We're going to lose our hegemony. Like, we're not going to be great, quote unquote. I mean, the rest of the world's going to go on without us. Like, the world's not going to wait for the U.S. to figure out that climate change is happening or accept the fact that climate change is happening. The world's not going to wait until we elect a competent leader. They're just going to do it. They're going to go off and they're going to make the world a better place. And we're going to be the sleeping giant of the West that eventually falls off the face of the earth and never to be seen again.
Right. And I mean, just on that note, and we can move on after this, but it's important to note that the rest of the world doesn't make as clear of a distinction as a United States citizen would between the wants and desires of the U.S. population and the administration that's in charge at any given time. So I think that's something important to note, that this is how we appear to the rest of the world. There's tons of people running around screaming, "Not my president." No, he is your president. Like, and this represents you. So once again, if as we've said on previous episodes, make the administration, as well as your senators, your congressional representatives, aware about your desires for the U.S. to be involved in climate change. There's a lot of things to make phone calls for as of late, but this should continue to be one of them. But
absolutely.
Moving on. Once again, we are not a politics podcast.
We're being forced into it. We don't want to do it. We're being forced to do it.
Seriously. Bad touch. International news. ESA unveils BepiColombo Mercury orbiters ahead of October 2018 launch. Jack, I have a quick quiz question for you. How many times have we sent orbiters to Mercury, or even flybys to Mercury?
Twice, right?
Yes.
Messenger and Mariner 10.
Boom! Wow, this guy's killing it.
Oh yeah.
I'm a witness, guys. He didn't even Google that, as far as I know.
No, it's up here next to how to eat,
right.
Sleep,
and random Simpsons episodes,
and random space facts.
So after almost 20 years of development, on July 6th, the European Space Agency finally unveiled the BepiColombo Mercury orbiters and confirmed that they're going to have a mission on October 2018. BepiColombo is Europe's first mission to Mercury. When it arrives at Mercury in late 2025, it will endure temperatures in excess of 350 degrees Celsius and gather data during its 1-year nominal mission with a possible 1-year extension. So Mercury is the smallest and least explored terrestrial planet in our solar system. As Jack said, we've only been there twice with Mariner 10 and Messenger. Mariner 10 was a probe whose primary objective was to observe the atmosphere, surface, and physical characteristics of Mercury and Venus. It was a $98 million probe launched back in 1973, and it captured the first ever observation of Mercury at close range. It photographed about 45% of Mercury's surface, and it gathered two important sets of data. First, it detected that Mercury, like Earth, has a magnetic field, which is important because Mercury and Earth are the only rocky planets in the solar system to possess global magnetic fields, except Mercury's is way more flimsy than ours. And a big reason for that is that Mercury spins so slowly on its axis. It's pathetic. No,
come on, Mercury, step up your game.
Step up your game, Mercury. The magnetic coupling between the magnetosphere of the dynamo and the planetary interior yields a weakened dynamo that can explain the weakness of the field, but we don't have time to go down that rabbit hole. The second discovery that was made by Mariner 10 was that the imagery data revealed a large number of craters on the surface of Mercury, which there's a host of reasons for that, involving both the beginnings of the solar system, as well as comets and things like that approach the sun. Our second journey to Mercury, which was Messenger, launched back in 2004 and arrived in 2011. So there has been a lot of recent is in the last few years, about Messenger. Messenger stands for Mercury Surface Space Environment, Geochemistry, and Ranging. And as it flew by Earth once, Venus twice, it was the first spacecraft to actually orbit Mercury. It completed its mission back in 2012, but helped us to discover large amounts of water present in Mercury's exosphere, which was totally unexpected. Nobody saw that coming. People went, this is super close to the sun. Why is there water here? It provided visual evidence of past volcanic activity on the surface of Mercury, demonstrated evidence for a liquid iron planetary core, helped us construct the most detailed and accurate maps of Mercury to date, and discovered carbon-containing organic compounds and water ice inside permanently shadowed craters near the North Pole of Mercury. So, actual water ice on the poles, which is
with organic compounds in it.
Yeah, which
like on Mercury.
and
right? And just for you listeners, so you said that Mariner 10 only captured, what was it, 40%?
45%.
45% of Mercury's surface.
Yeah.
Messenger captured 100% of the surface. Like you said, it was the first to go in full orbit.
Correct.
With over 100,000 images.
Yeah. It was. And I don't know how many of those you've seen. They're on NASA's website, but I mean, it's pretty cool. And it got some great imagery as it was decaying into Mercury, as it was on its way down. It was pretty cool.
Oh, yeah. Everyone should know that Messenger is still at Mercury. It just crashed because it ran out of fuel, and it was better than just letting it out there. It's kind of an interesting planetary protection argument. Just let it crash on Mercury where everything on it will die, as opposed to let it stay in orbit and maybe get sucked into Venus.
I mean, we litter our planets all the time too. That's like that's like a well-known human thing. We must protect what's on this planet. Yeah, just let it fall into the
just let it fall there.
Right. So as far as BepiColombo, they're going to have 2 spacecraft on board this mission: the ESA's Mercury Planet Orbiter and JAXA, the Japanese space agency's Mercury Magnetospheric Orbiter. So that's the MPO from ESA and the MMO from JAXA. MPO is going to focus on the planet, its surface, and interior size. It's going to have a polar elliptical orbit. According to these numbers, it's going to be 480 kilometer by 1,500 kilometers. So very elliptical, but also be super close. And that'll be about a 2.3 hour orbit. And they're estimating that it's going to return 1.5 gigabits of data a year. Once at Mercury, the orbiters are going to separate and move into their own orbits to make complementary measurements of Mercury's, like I said, interior surface, exosphere, and magnetosphere. So just constant surveillance of the planet. The information is just going to tell us more about the origin of the solar system and the evolution of a planet that's that close to its parent star, and that gives us, once again, a better overall understanding of the solar system. So the craft is almost ready. They just went through some final acoustic chamber testing last month and vibration testing last week, and are basically ready to go. They're dismantling it and preparing the transfer module for its last test in the thermal vacuum chamber. This will check it that it can withstand the extremes of temperatures en route to Mercury. They'll be going through the final qualification and acceptance review of the mission in early March 2018 and planning to ship it to French Guiana in preparation for the October 2018 launch. So shout out to ESA and JAXA for getting us to Mercury for the third time, getting humanity to Mercury for the third time.
Yeah. So another cool thing I just looked up. So TRAPPIST-1 are the first
space what's that?
News.
No, I'm just kidding.
The first space news highlight of the week that we ever had. So if you remember those, us studying Mercury is going to allow us to study TRAPPIST, because all of those planets, B through H, are within the distance between our sun and Mercury. So their star, the distance between their star and their last planet is still smaller than the distance between our star and Mercury.
Right.
So if there's life on Mercury, or maybe not life, but if there's evidence that it's an acceptable biosphere, I guess you'd call it, atmosphere for organic compounds and water, then very well TRAPPIST could have life.
Right. Further study of Mercury's atmosphere would be extremely, or magnetosphere in this case, would be extremely valuable.
Yeah. There's a table on the Wikipedia page for BepiColombo that goes through how many flybys. So like you were saying with Messenger, that it had 3 Mercury flybys and 2 from Venus, 1 of Earth. This one's going to have the BepiColombo is going to have 1 of Earth, 2 of Venus, and 6 Mercury flybys.
Wow. That's going to be amazing. I can't wait. And once again, it's ESA's first venture over to Mercury. So this should be interesting.
Yeah.
Okay. So on to latest in tech. NASA Pluto probes next target may actually be swarm of objects. So what Pluto probe could we possibly be talking about? New Horizons.
Isn't that... Oh, I was going to...
Sorry.
Isn't that Messenger?
I swear to God, Jack. So the New Horizons space probe, which made headlines around the world back in 2015 when it basically finalized is probably not the best word, but it gave us coverage of the solar system in that we've officially sent craft to explore each planet or dwarf planet in this case of the solar system. It beamed back humanity's best ever views of Pluto, and we've been collecting data from that ever since, but that was just a flyby. New Horizons is continuing to hurtle through the outer reaches of the solar system and right now it's on its way to rendezvous with a lump of ice known as MU69. Now, it won't get there for about a year and a half. The flyby is expected to occur either on December 31st, 2017 or December 31st, 2018 or January 1st, 2019, which is going to make for an awesome New Year celebration. I don't know what we're going to do yet, but we're celebrating it.
Oh, there is going to be a party. If you're in DC, stay tuned.
Yeah, we just have to figure out how to celebrate when it gets there, given that the Kuiper Belt is so far away and anything could have happened within those, I want to say, 9 hours.
Yeah, I mean, that just means we have to party for 9 more hours before we get confirmation.
That's true. It's going to be about 43.4 AU from the sun on this flyby. So just a reminder, that's taking the distance between the Earth and the sun and multiplying it times 43.4. So it's very, very far away. That's less than a kilobit per second. It was less than a kilobit per second when it was at Pluto. And now it's going all the way out here. But anyway, using a technique called occultation, scientists discovered a significant amount of information about the area around this new target, MU69. And there's no time to dive into it, but occultation is a technique for gathering data by observing an object's quick pass in front of a star. In this case, using a large number of pre-positioned mobile telescopes to do so. According to Alan Stern, the now famous PI of New Horizons, there may be a large number of objects around MU69. He was quoted as saying that, quote, that either MU69 is highly reflective, and smaller than some expected, or it may be a binary or even a swarm of smaller bodies left from the time when the planets in our solar system formed, which would be end quote, that would be a very interesting result. And as a brief coming soon to space, for this reason, on July 17th, Hubble will check for debris around MU69, while team members set up another ground-based fence line of small mobile telescopes along the predicted ground track of the occultation shadow in southern Argentina to try to better constrain or even determine the size of MU69. So, Jack, what was New Horizons valued at while we're giving Jack space trivia? How much did it cost? And I'll give you a hint. It was between 2001 and 2016. That's what we're calculating this value over.
I'm going to say it 1.45 billion.
Lower. No? Lower.
800 million.
Lower.
250 million.
That's ridiculous. It was $700 million.
I was close with 800 million.
You were close with 800 million. And like, it's the gift that keeps on giving for $700 million. And granted, exploring the Kuiper Belt is part of its mission, but it was one of those things where, yes, you can say for certain we're going to explore Pluto. Yes, you can say for certain we're going to be exploring some of the items that share the orbit with Pluto, because Pluto does not own its own orbit. But to be able to kind of alter the mission to go find interesting items in the Kuiper Belt is an extremely impressive feat. And it's sending back extremely meaningful data for something that was only $700 million to build. Like, I know it seems like a lot of money, but $700 million over 15 years for government spending, dropping the ball.
The government probably spends that in like a day.
Right.
Like normally, like just in the total grand scheme of the budget, that's a couple days, maybe tops.
Right.
But I mean, New Horizons, and it's one of those things that, we were talking earlier about, there's not as much pomp and circumstance around robotic missions. This is one that actually gets some. I mean, like, you have people like Brian May, like the lead guitarist from Queen, worked on the New Horizons because he went back and got an astrophysics degree and went out and publicized it and talked about it. I mean, this is something that encapsulated a lot of different people and a lot of different skill sets, and thusly had a lot of people out supporting it and communicating about it. I don't think BepiColombo is going to have as big of a splash.
No.
unless they send a picture of like little green men walking on the surface of Mercury, which
be afraid. If that happens.
a lot of crazy stuff has happened in the last 2 years. I think that might just take the cake, though.
Yeah, you know what? After last year, I wouldn't even be surprised. But anyway, if you told me that, I just go, okay. I just shrugged my shoulders.
That's where the 2.3 million votes were.
Right, exactly.
Ooh.
He shoots, he scores. Anyway. Moving on.
Yeah, so you heard about Juno, right?
I have heard. I've heard something about this Juno. Real quick before we switch off to that, I want to say that just a couple more facts about New Horizons. The mission will be ending in 2026 based on RTG plutonium decay, and thanks to Newton's first law, it will be at 100 AU from the sun. I want to say I believe it's 2068, but. We'll get there. I'll get that number for you guys.
Yeah, and let's so that's New Horizons is just going to keep going. Granted, we're not going to be able to communicate with it or receive any data from it.
2038.
2038. 100 AU.
Yeah, it'll be 100 AU in 21 years. Yes. Okay.
Jeez.
It'll be right there along with the Voyager spacecraft.
Yeah, how far away is Voyager? Voyager 1 is...
Well, I believe it's going to tag up with Voyager because, I mean, it's going faster. Well, it will be going faster. Yeah.
Yeah. Well, I mean, if you're able to get to Pluto in like 8 years,
right?
That's pretty fast. I mean, Voyager, it was like 15 years of getting out there, if not longer. But yeah, so I mean, this is going to be something to watch. Again, we're not going to be able to receive any data from it after a while, after this 2026. You said, but being able to track it and say, hey, there is something man-made 200 AU out by 2086 or whatever it's going to be.
So as point of fact, JPL has on its website where Voyager is, as I expected they would. Voyager 1 is 138 AU from Earth. That's 139 AU from the sun. Just quick math. And then Voyager 2 is 114 AU from Earth.
That is a really cool widget, and I wish I had that on my phone.
Right? I could use one of
somewhere. just keeps track of the distance Voyager is. And I mean, that's all approximation. Like, we're not getting any data from Voyager anymore. Correct? I mean, this is all an approximation, but that stuff's out there, folks. And New Horizons will be out there too.
I could be wrong. I don't want to say something wrong, so I could be wrong when I say Voyager, I don't think is sending any weird form of a ping. I mean, we would, as far as I know, we wouldn't be able to receive that and know that it was Voyager, right? It would be such a small signal. So
yeah.
That's something we can look up.
Who knows? Maybe SETI's going to pick something up and we'll think it's life, and turns out it's just Voyager coming back from the dead.
That's going to happen in like 10,000 years, I'm sure. 40,000 years, maybe. All right. So, moving on.
So Juno. So, do you know about Juno? It is.
I know.
It's making another flyby of the gas giant, the wonderful, the magnificent Jupiter. And this time, and actually, it's happening right now as we're recording this.
It's true.
I think it was it's at 10.
No, half hour. We've got a half hour.
Oh, we got a half hour. 9:55 p.m.
Yeah.
July 10th. So if you're listening to this on Wednesday, remember where you were 2 days ago, or like a day and a half ago if you're listening to this in the morning.
At 10:06 p.m.
because
time.
This is going to be a really interesting thing because it's going near a spot that I don't think there's ever been an astronomer that hasn't seen this.
No.
It's Great Red Spot.
It's the most curious spot in the solar system.
It's 10,000 miles wide.
It is 10,000 miles wide and could fit about 3 Earths inside of it.
Don't worry, folks. We're not actually going to test that.
So this is going to be the probe's 6th science flyby of Jupiter. We talked about this a few weeks ago and just some of the amazing pictures that Juno has taken. But this time, this is going to provide humanity with its first up-close looks at the Great Red Spot, which astronomers have been monitoring that since, I think it was discovered in 1830.
1830 is the date I see here.
1830, exactly. Okay. It's going to gather even more data about Jupiter's composition and interior structure by sort of measuring those things in the context of the actual storm. And according to NASA officials, all 8 of the spacecraft's instruments, as well as its imager JunoCam, will be turned on during the flyby. And so will we. No, I'm just kidding. But this is something where the spacecraft is going to want to be doing as much monitoring as possible to collect as much data as possible. Now, I've briefly covered some of the tools that are on the Juno spacecraft, but I wanted to chat about them a little bit more in this latest in tech section and just kind of give you guys a brief rundown of each of the 8 main instruments that are on board Juno. So you have the gravity science instrument, which is basically a radio science instrument that involves the X-band and Ka band ranging from ground stations on Earth to follow the spacecraft in its orbit around the planet and detect even the smallest changes in motion of the spacecraft. Local variations in gravity can act on the spacecraft in orbit and cause it to speed up or slow down. So analysis of those changes in gravity feeds you more information about the planet. There's the magnetometer, which, it's like the one that's in your phone, right? The magnetometer in your phone. Okay, maybe it's a bit stronger. Juno is using what's called a fluxgate magnetometer that was developed at NASA Goddard, and is installed on one of 3 solar arrays of the spacecraft to move the instrument as far away from the spacecraft platform to avoid false readings caused by Juno's own magnetic emissions. It uses a set of dual fluxgate magnetometers to measure the magnetic field vector, and 3-cell scalar helium magnetometer sensor provided by JPL is used to measure the strength of the field. A few more here. The microwave radiometer, or MWR, on Juno studies the hidden structure beneath Jupiter's cloud top. So this one's very important for the actual storm. It's capable of determining on the structure, movement, and chemical composition to a pressure of 1,000 atmospheres, which corresponds to a depth of 550 kilometers below the cloud cover. Its goal is to determine the abundance of water and ammonia in the Jovian atmosphere. And so that's going to have some very interesting readings when analyzing whatever this storm is composed of. I don't know that information. In addition, there's Jupiter Energetic Particle Detector Instrument, or the JEDI. It measures energetic particles. Tom, throw that sound in there, but make it stronger. It measures energetic particles and their interaction with Jupiter's magnetic field. And it investigates Jupiter's polar space environment. That's usually its main purpose, with special focus on the physics of the intense Jovian auroras. You could imagine that a particle detector like that is going to become extremely excited once it's analyzing and is above this storm. There's the Jovian Auroral Distributions Experiment, or JADE, and it works with a couple of the other sensors, the JEDI and the UVS, the ultraviolet spectrograph, to study the particles and processes that form Jupiter's powerful auroras as well. It has 4 deck-mounted sensor packages, which include 3 electron analyzers and a single mass spectrometer, each with a field of view of 360 by 90 degrees and 270 by 90 degrees, respectively. And that electronics box contains all instrument electronics except preamplifiers, which reside inside the electronics vault. A few more here. There's the radio and plasma wave sensors, or waves as they call it. It measures radio and plasma waves in the Jovian magnetosphere to help understand interactions between Jupiter's magnetic field, the magnetosphere, and the atmosphere. So also, a major player in the analysis of this storm. The ultraviolet spectrograph, which I mentioned earlier, images and measures the spectrum of the Jovian aurora in the 70 to 205 nanometer range of the electromagnetic spectrum. This one's also going to come alive during the storm. The 2 more, the Jovian infrared auroral mapper, or JIRM, combines an infrared imager and spectrometer to obtain high-resolution images of Jupiter's atmosphere and auroral display, just in those ranges of the electromagnetic spectrum. So we're just kind of covering the electromagnetic spectrum in fine-grained devices for each of those wavelengths. And last but not least, Juno Cam, which is a camera. It's a visible spectrum camera to deliver full color images of the Jovian atmosphere. So we're going to get some awesome images of the storm. That's probably where most of the images that you're going to see on the internet will be. So that one's really big for use in public, in education and just public outreach and scientific studies that are conducted by grad students worldwide. So this one, all of these things are going to get flipped on. We're going to be looking at the electromagnetic spectrum in multiple ranges, and attempting to detect every single thing that we possibly can about this storm that we have been curious about for the last 187 years. And that is happening within 20 minutes of this recording.
Yeah. So, and this is actually going to be one of the last expected successful Juno Cam operations. Noted by the Juno team that September 1st, or around September 2017, is going to be the first time that they're expecting any problems with the Juno Cam. And that's likely to cause problems within the rest of the spacecraft. This was a spacecraft designed to only be in orbit of Jupiter for a little over a year. It just reached that year mark on July 4th. Very fitting. But yeah, it's every 56 days it goes through its orbit around Jupiter and gets close enough to take these photos and make it look good, and to capture these measurements that are so important for this for the science that we're doing. And the extended mission for Juno might last into 2018 or 2019. But I wouldn't be surprised if this might be one of the last times that we see Jupiter through Juno Cam. You had to save it for the big red storm. That's oh, absolutely.
Things.
this is going to be everybody at NASA's and everybody in the space community's desktop background for like the next until Pluto finds something, or until New Horizons finds something cool, or Curiosity does something cool. I need to change my desktop background. So here's my question for you. How much did is Juno expected to cost over its lifespan?
That let me see.
I'm
gonna guess less. It's less than New Horizons. Well, I would say actually I would put it on par with New Horizons because of dealing with Jupiter's radiation and magnetosphere. It may be like, I would say 900 million. Actually, maybe a little more than New Horizons.
It's more.
How much?
Try 200 million more than that.
$1.1 billion. Okay.
Yep.
Okay. That's reasonable. Yeah. When you account for the radiation that it has to deal with, and just staying stable around a massive object like Jupiter, the aerodynamics, software, staying stable in that kind of orbit. That's, and the telecommunications, like the effect that Jupiter's atmosphere has on telecommunications and things like that. I can see that costing a significant amount.
Yeah, and it's a lot bigger than New Horizons. New Horizons is a small spacecraft.
Yeah, it's just a little guy. Yeah.
Whereas Juno, I mean, with the 3 outstretched arms, Juno is, I think, it's about 1,600 kilograms, and it is what is the
20.1 by 4.6 meters.
Oh, I see that. Yeah. That's 66 feet for us Americans.
Yeah. 66 by 15 feet. Yep.
Yeah. That's pretty big.
Pretty huge.
Huge. But yeah, so that's something to look forward to. I don't think the images won't be out for a while.
No, they've got to collect and verify again, and
Photoshop the UFOs out,
and then Photoshop the transformers out, and all of that. So yeah, it's got a while.
Yeah, and they will also be releasing the raw data and the raw images to the public. That's something that's been cool about Juno, is they've been releasing those, and people will take them and do their own post-processing and filtering and all that with that data. And it's, I mean, just go to the Juno mission page on NASA's website, and it's just a treasure trove of desktop wallpapers and interesting reads.
Right. So we mentioned this before just briefly because we're almost out of time here, but Juno is actually spinning continuously. It's a part of basically how there's sort of an algorithm to how it's taking taking pictures and stabilizing itself, and due to that it has to continuously spin just to maintain sort of a stable orbital state around Jupiter. So you could imagine that would create these sort of layered pictures as it's taking images, especially those in the visual spectrum. So the processing that Jack's talking about is sort of taking into account that spin and trying to come up with sort of these clean images from these sort of layered pictures. So you can take a look at Juno's website. We'll have it in the show notes, and you can see a little bit more of what I'm talking about there. So yeah, you got anything else on Juno?
That is it on Juno. I'm looking forward to these pictures. I'm looking at them now. I pulled up the website, and it's just, I think Jupiter might be my favorite planet, but that's
pretty partial to Earth.
I mean, non-Earth.
It has some good species. It has some pretty terrible species, but
well, I would say non-Earth planet. Earth is my favorite as well.
Yeah, it
has its problems, but at least it's habitable.
Yeah.
Jupiter, second favorite planet.
I don't know. Saturn's pretty dope.
You're right. Oh,
Saturn's
the rings.
Pretty dope. Those rings.
It's a tie. Jupiter was what got me into space. Seeing Jupiter and the Galilean moons that's what got me.
Yeah.
So it's always going to hold that special place in my heart, no matter how cool Saturn is.
Yeah. That one's always a hard one for me. I'm gonna ride that fence for a while.
Yeah. So everybody who's listening, we want to hear what your favorite planet is. So comment.
Yeah, let's do that.
Comment on the Facebook post or Twitter or however you're getting your news. And
your favorite non-Earth planet.
Favorite non-Earth planet.
Yeah, you're not allowed to say this one. Or if you really don't like this one, tell Jack why.
And you also can't pick Pluto, because I know so many people are just going to pick Pluto.
No, that's not even going to be an option in the survey.
Oh, yeah, we should do it by the reactions on Facebook.
All right. Anyway, in our coming soon to space section, just a real quick story on this one. So NASA planning August release of Mars robotic exploration architecture. So there are these plans for a 2022 Mars orbiter. A NASA official said today, July 10th, the date of this recording, that the agency plans to have a quote, coherent Mars architecture, end quote, for future robotic Mars missions ready for presentation at an August committee meeting. No major details were given or anything like that, so this isn't really a mega story here. But Michael Meyer, the lead scientist for the Mars exploration program at NASA headquarters, was reported as saying that the architecture is on track to be presented at a meeting in late August of a National Academies Committee reviewing progress NASA has made implementing the Planetary Science Decadal Survey published back in 2011. Wow, only a few more years until the next one. So best of luck to the folks who are pitching this coherent Mars architecture and planning this future 2022 Mars orbiter. We'll let you know the details as we get them.
Absolutely. So yeah, other than that, just make sure that you are following us on Twitter. We're getting better and better every week with posting things. Follow us on Facebook. We're a lot better on there than we are on Twitter. Follow us individually. Review us on iTunes. Follow us, recommend us on Overcast. All the fun things. We'll keep you entertained with our fun articles and cool things that we keep putting out. So if that's all we got for this week, that's all I got.
That's all I got too. So
all right. Well, as always, I'm Jack.
And I'm Newton.
Ad Astra.